Hey guys, tonight we are going on a journey. We'll be stepping back in time. Not just a little way, but so far that the light from the stars you see now was just beginning its long, slow voyage. We are going to drift on a river of ages, and we'll arrive at a shore where giants walked, but not the kind you're used to seeing in movies. These were creatures of bizarre proportions and stranger habits, living in a world that would feel like a fever dream. A world where the air was thick with the scent of ferns and ancient pine, where strange, flitting things rustled in the undergrowth, and where a single footstep could make the ground tremble. Honestly, you probably wouldn't survive 5 minutes there, but that's the beauty of it. We don't have to. We can simply observe, like ghosts in the mist. So, before you get comfortable, take a moment to like the video and subscribe. But only if you genuinely enjoy what I do here. Let me know where you're listening from and what time it is for you. Maybe you're on the other side of the world, bathed in the glow of a different moon. Or perhaps it's a quiet morning and the sun is just beginning to peek through your window. In a moment we will begin. Just close your eyes and let the long echoes of the past wash over you. Our journey begins not with a roar, but with a whisper. The whisper of a name that has been misunderstood for over a century. A name that conjures a thief, a monster, but tells a story of an entirely different kind of creature. We're talking about the Oviraptor, which literally means egg thief. It's a name given by paleontologists in the 1920s, who found a skeleton curled up on top of a nest of eggs, and immediately assumed the worst, a criminal caught in the act. But how often does our first assumption, our quickest judgment, capture the full and complex truth of a situation? The truth, as is so often the case in science and in life, is far more subtle and beautiful. Imagine a tapestry woven by history. The threads are not always what they seem. When those first scientists, the pioneers of the fossil hunt, saw the Oviraptor, they saw a thief. But what if we could pull a single thread and reweave that part of the story? The first hint of a new pattern came decades later, with more careful excavations. It was discovered that the eggs in that nest almost certainly belonged to the very dinosaur sitting on them. The egg thief was, in fact, an exceptionally devoted parent, a mother or father diligently guarding their clutch. This small, elegant detail changes everything. It transforms a villain into a protector, a symbol of greedy predation into one of nurturing and care. It's a powerful lesson in how our understanding of the past is always evolving, always being corrected by new evidence. It's a testament to the fact that scientific truth is not a rigid statue, but a flowing river that changes its course with every new stone uncovered. This reminds me of a core scientific concept, one that's a bit strange but deeply intuitive if you let your mind wander. The principle of superposition. In geology, this principle states that in an undisturbed sequence of rock layers, the oldest layer is at the bottom and the youngest is at the top. It's a fundamental idea, and it's how we first started to make sense of deep time. It's like a stack of forgotten letters. The one at the bottom was written first, and the one on top most recently. Each layer, each letter, is a snapshot of a moment in time, frozen and preserved. But the Oviraptor story shows us that simply looking at the layers isn't enough. We have to look at the relationships between the things we find within them. The egg, the fossilized skeleton, the context of their placement. These things tell a story that goes beyond simple age. They reveal behavior, intent, and life. The Oviraptor wasn't a static layer in the Earth's history. It was a living, breathing creature with a purpose. And what a creature it was. The Oviraptor's body was a study in paradoxes. Imagine a bird, but not quite. It had a strange, toothless beak, a bit like a parrot's, and its head was often adorned with a bony crest, a casque that might have been used for display, much like a cassowary's. Its arms were short and ended in three-fingered hands, and its body was covered in feathers. This is one of the most remarkable things we've learned about these dinosaurs. We don't just find fossils of bones. Sometimes, under the right conditions, we find impressions of soft tissue, of skin and feathers. These preserved imprints show us a creature that was not a scaly reptilian monster, but something far more avian and delicate. Its feathers would have been bright, maybe iridescent for attracting a mate or intimidating a rival. So, the Oviraptor, the egg thief from our imagination, was likely a shy, feathered parental figure, perhaps singing soft calls to its young. This brings us to a beautiful paradox in evolution, one that is not fully understood. It's called evolutionary paradox, and it happens when a species seems to develop a trait that doesn't fit its environment or lifestyle. Why would a small, fast-moving creature, like the Oviraptor, have a strange crest on its head, or a beak that looks more suited for cracking nuts than for biting prey? The truth is, we don't really know for sure what all these features were for. Perhaps the crest was for communication, or for regulating body temperature. Perhaps the beak was more versatile than we imagine, used for pecking at plants or insects. This raises an interesting question. Do all traits have a clear and obvious purpose? Or are some simply the result of an ongoing, unpredictable evolutionary experiment, a beautiful mistake that just happened to work out? The Oviraptor story is a profound one because it forces us to confront our own biases. We looked at a scene and saw a crime, but the universe was showing us an act of love. It reminds us that the past is not a static museum. It is a living, breathing narrative. And we are constantly rewriting the script with every new discovery. The journey of understanding the Oviraptor is like walking into a darkened room and slowly, piece by piece, turning on the lights. At first, you only see a shadow, a menacing shape. But as more light spills in, you realize the shadow isn't a monster at all, but a beautiful protective parent. Its feathers a gentle cloak against the harsh winds of time. And so, with this soft and strange creature, we begin our exploration of the weirdest dinosaurs that ever lived. Those who defy our expectations and invite us to look a little closer. The gentle ghost of the Oviraptor's devotion fades now, and we drift on the currents of deep time, leaving the terrestrial plains behind. Our journey takes an unexpected turn, downward, into the shimmering depths of the ancient ocean. This is where we will meet a creature that, in the popular imagination, is often lumped in with the dinosaurs, but is in fact something else entirely. Something just as magnificent, just as terrifying, and a little more mysterious. I'm speaking of the Mosasaurus, a ruler of the late Cretaceous seas. If you've ever looked at a modern lizard, perhaps a Komodo dragon, and thought it was an awe-inspiring creature, you have a small hint of what the Mosasaurus was like. But you would have to stretch that idea to a colossal scale. Imagine that lizard elongated, its legs replaced by powerful paddle-like flippers, and its tail flattened into a massive muscular rudder. Its jaws were lined with rows of sharp, backward-curving teeth, and it could open them in a way that suggests it could have swallowed prey whole, much like a snake. This magnificent predator was not a dinosaur. Dinosaurs were land-based. The Mosasaurus was a marine reptile, a member of a different lineage that returned to the sea. Much like modern whales are mammals that returned to the sea. The sea is a great canvas for evolution, and sometimes it paints the same picture more than once. This brings us to a beautiful and fundamental concept in biology: convergent evolution. It's the idea that unrelated species, living in similar environments or facing similar challenges, can evolve similar traits and body plans. Think of it like a problem and a solution. The problem is navigating the water, and the solution is a sleek, torpedo-shaped body with fins. A shark is a fish, a dolphin is a mammal, and the Mosasaurus was a reptile. They all occupy a similar predatory niche in the ocean, and their bodies have all converged on a similar design. It's as if the universe has a set of favorite blueprints, and it uses them over and over again, in different materials, with different histories. A shark's fins are made of cartilage, a dolphin's of bone, and a Mosasaurus's of bone and muscle. Yet they all perform the same function, all shaped by the same pressures of the deep. It is a testament to the elegant, often repeated logic of nature. The Mosasaurus itself was a titan of the ocean. The largest species could reach up to 50 feet in length, longer than a bus. Their reign was absolute. They sat at the very top of the food chain, preying on everything from fish to other marine reptiles, and even turtles whose shells would have been no match for those powerful jaws. The thought of a creature like this, gliding through a sea that no longer exists, is both thrilling and humbling. It makes you feel small, like a single grain of sand on a vast beach of time. The sheer scale of it all, the immense length of its body, the unfathomable depth of the ocean it inhabited, stretches the imagination. There is a strange and beautiful detail about these creatures that is a puzzle for scientists. Some fossilized remains of mosasaurs show what appear to be healed fractures in their ribs and jaws. This suggests they were not immune to injury, perhaps from battles with other mosasaurs, or from grappling with particularly feisty prey. The truth is, we don't know for sure what kind of life they lived. Were they solitary hunters, or did they live and fight in packs? Did they have a complicated social structure, or were they simply roaming predators, living out their lives in a kind of magnificent, violent solitude? This raises a quiet philosophical question. What is the true nature of a predator? Is it simply a killing machine, or does it have a life, a purpose, a history beyond its role as a hunter? The fossil record shows us the what, but often leaves us to wonder about the why. Thinking about the mosasaurus also brings to mind an intriguing fact about the human body, an example of our own evolutionary heritage that is often overlooked. Our ability to sweat is a critical thermoregulatory function that allows us to run long distances, something many other animals cannot do. This is a subtle but powerful example of an adaptation that, on the surface, seems simple, but in fact defines a core part of our biology. It's like the fins of the mosasaurus, or the flukes of a whale, an elegant solution to an ancient problem, in our case, the problem of endurance hunting. We may not look like the great creatures of the past, but the echoes of their adaptations are all around us, in the way we move, in the way our bodies work. The story of the mosasaurus is a story of a lost world, a world where the ocean was ruled by reptiles instead of mammals, and a world that challenges our tidy classifications. It reminds us that nature does not fit into neat boxes. The lines we draw between different types of animals, lizard, dinosaur, bird, are our way of making sense of things, but the truth is often more fluid. The mosasaurus, not quite dinosaur, not quite whale, is a living example of this fluid reality, a beautiful scaled contradiction. It is a ghost from the depths, a reminder that the land is not the only place where giants once walked. And now, we leave the silent water behind, ready to return to the earth, where a new kind of fortress awaits. We have journeyed from the gentle parent of the plains to the great predator of the deep. And now we return to the land, to a different kind of survival. We are going to meet a dinosaur that didn't rely on speed or a fearsome bite to live, but on patience and an impossible suit of armor. We are going to encounter the ankylosaurus, a living fortress of bone, a kind of biological tank, a slow and steady fortress wandering through a world of giants. Imagine a living creature that looks as though it was built by a medieval blacksmith. Its body was broad and low to the ground, almost like a living shield. Its entire back, from the tip of its snout to the end of its tail, was covered in thick, bony plates, called osteoderms, that were embedded directly in the skin. The word ankylosaurus literally means fused lizard, a name that perfectly describes the way these plates were fused together, creating an almost impenetrable dome of protection. Along its sides and head, sharp spikes protruded, adding to its formidable defenses. And then there was the tail. The final, elegant, and devastating detail was a massive bony club at the end of its tail, a weapon so heavy and powerful that it could have easily shattered the leg of a large predator, like a Tyrannosaurus rex. It was an animal designed not for the hunt, but for defense, a walking contradiction in a world of fierce giants. This brings us to a beautiful and powerful idea in biology, the evolutionary arms race. This is a concept where a predator and its prey, or a parasite and its host, continuously evolve in response to each other. The predator gets faster, so the prey gets faster. The parasite gets better at infecting, so the host gets better at resisting. In the case of the ankylosaurus and its predators, the armor of the herbivore and the biting force of the carnivore were locked in a kind of ancient dance. As the predators evolved stronger jaws and teeth, the ankylosaurus would have evolved thicker armor and more menacing spikes. This cycle of escalation is a core engine of evolution, a constant push and pull that shapes the most incredible creatures. The ankylosaurus is a stunning snapshot of this race, a monument to the lengths that life will go to in order to survive. Think of it like a Cold War, played out over millions of years, with the body of a creature as the battleground. The ankylosaurus wasn't fast. It wasn't particularly clever. Its strategy was pure, unyielding defense. It would simply hunker down, a low, spiky dome, and wait for its attacker to give up. The tail club was its last resort, a powerful swinging hammer to repel any who got too close. This single-minded focus on defense is a reminder of the many different paths to survival. A creature doesn't have to be the fastest or the most cunning to succeed. Sometimes the best way to win is simply to not lose. There is a quiet mystery about the ankylosaurus that remains. The bony plates that covered its body, the osteoderms, are similar to those found in modern crocodiles and armadillos. But we don't know for sure how they felt or what their exact purpose was. Were they covered in skin, like an armadillo's shell? Or were they exposed bone, a kind of natural rock formation on the animal's back? And what about the spikes? Were they just for defense, or did they serve some other purpose, perhaps for display during courtship? This raises an interesting question. What is the line between utility and aesthetics in nature? Do all of a creature's features have a clear, singular purpose, or are some of them simply beautiful, a kind of flourish that life added along the way? The truth is, we don't really know for sure. This ponderance on the nature of armor brings to mind a subtle, little-known scientific fact about our own bodies. Our bones, which we think of as hard and static, are in fact a kind of living, breathing tissue. They are constantly being broken down and rebuilt in a process called bone remodeling. It's a bit like the ankylosaurus's armor, but on a microscopic scale. Every 10 years or so, we have an entirely new skeleton, a constant cycle of construction and deconstruction. It's an example of how something that seems permanent and unyielding is in reality a dynamic and ever-changing system. It's a reminder that even the hardest things are in a constant state of flux, always being shaped and reshaped by the quiet forces of biology. The ankylosaurus is not just a collection of bones. It's a story, a fossilized poem about resilience. It's a testament to the fact that strength can be found in stillness, in waiting, and in being so well protected that you can simply weather the storm. It's a beautiful, armored beast that teaches us that sometimes the most effective way to survive is not to fight, but simply to endure. Its story is one of patience, and in that, there is a deep sense of peace. And so we leave this slow, armored fortress, and our journey continues to an entirely different kind of dinosaur, one that chose a different path in the ancient world. From the silent armored fortress of the ankylosaurus, our path veers sharply, leading us to a creature that is a kind of beautiful, scaled contradiction. We're moving from the unassailable to the utterly unique, to a dinosaur that looked as though it were the fever dream of a desert nomad. We are going to meet the spinosaurus, a beast of the ancient riverways, and a creature that redefines everything we thought we knew about the life of a great predator. Imagine a crocodile, but one that walks on two legs. Now imagine a sail, tall and elegant, rising from its back, supported by long, spiny bones. Finally, imagine that this creature is as long as a city bus. This is the Spinosaurus. For a long time, we knew it only from fragmentary remains, and it was a source of great debate. Was it a land-based hunter? Was the sail for display, for attracting a mate? The first major fossils were destroyed in World War II, leaving paleontologists with little more than old sketches and notes. It's a powerful reminder that our connection to the past is fragile, that a single act of history can erase a chapter of a story that took millions of years to write. But in recent decades, new discoveries have completely rewritten the story of the Spinosaurus. We now have a more complete picture, and what it shows us is that this was not a land-based predator like a T-Rex. Instead, it was a semi-aquatic giant, a creature that spent a significant portion of its life in the water. Its powerful tail was paddle-like, and its snout was long and narrow, filled with conical teeth perfectly suited for catching fish. The sail on its back, once thought to be for display or thermoregulation, may have also been used for swimming, a kind of elegant fin-like structure that helped it navigate the ancient rivers of North Africa. The Spinosaurus was not a dragon of the land, but a kind of majestic living ship, a hunter of the water. This is a wonderful example of how ecological niches shape anatomy and behavior. An ecological niche is like a species' job in its environment, what it eats, where it lives, and how it interacts with other creatures. The Spinosaurus had found an available niche, a large, apex predator of the water. Over millions of years, its body was slowly sculpted by the demands of this life. Its legs became shorter and more compact. Its feet became broader, and its tail became a powerful engine for propulsion. This is a subtle but profound concept. It tells us that a creature's form isn't random. It is a direct result of its purpose in the world. The Spinosaurus, with its crocodile-like snout and fish-eating diet, is a living blueprint of its unique place in the ancient ecosystem. Thinking about the Spinosaurus also makes me contemplate a strange phenomenon in biology that is not entirely understood. It is known as adaptive radiation, where a single species diversifies and rapidly evolves into many different forms to fill a new or empty ecological niche. The Spinosaurus did not just appear out of nowhere. It was part of a lineage that was slowly adapting to the water. But the speed and scale of this transformation are still a mystery. What was the exact moment when its ancestors committed fully to a life in the water? The truth is, we don't really know for sure what specific environmental pressure led to this radical change. Was it a lack of land prey? A sudden abundance of fish? This raises a quiet question. Are these grand evolutionary shifts the result of a single dramatic event? Or are they the quiet accumulation of a million tiny steps? A slow, gentle drift toward a new way of being. This journey of the Spinosaurus from land to water is a mirror of a more subtle process we see even in our own world. Consider the simple concept of osmosis, the movement of water across a membrane to equalize concentrations. It is a fundamental process of life, a quiet and constant flow that underlies everything from the function of our cells to the movement of water in plants. It's a process that seems simple, but its elegant logic is essential for all life. In a way, the Spinosaurus's evolution was a kind of osmosis of its own, a slow and steady flow toward a new and perfect place for itself in the world. Its body was a membrane, allowing it to transition from one realm to another, from land to water, and in doing so, it became something truly unique. The Spinosaurus is a testament to the strange twists of adaptation, to the beautiful and unexpected forms that life can take. It's a story about a creature that chose a different path, that found its home not on the solid ground, but in the flowing embrace of the river. Its great sail, a kind of living flag, reminds us that the past is full of surprises, and that the story we thought we knew is always waiting to be rewritten. And now, we leave this elegant sailing hunter, and we shrink in scale to a creature that reminds us of a different kind of life entirely. We have journeyed from the immense to the armored, and from the terrestrial to the semi-aquatic. Now, let's change our perspective entirely. We are going to zoom in to focus on a creature of such small and delicate proportions that it seems to defy the very idea of a dinosaur as a lumbering giant. We are going to meet the compsognathus, a dinosaur that was hardly bigger than a chicken, a kind of ancient shadow that flitted through the undergrowth of a world we can only imagine. Imagine a small, graceful reptile walking on two slender legs, its body covered not in scales but in a delicate coat of downy feathers. It was no taller than your knee and moved with the quick, darting motions of a modern bird. The name compsognathus means elegant jaw, and it was a fitting name for a creature that was a study in a kind of miniature perfection. It was a predator, but it preyed on things you might swat away in your own home: insects and small lizards. Its place in the ancient world was not one of a roaring tyrant, but of a quiet, efficient hunter, a kind of living, breathing jewel in the vast, dense tapestry of the past. It's a powerful reminder that the story of the dinosaurs is not just about the giants. It's also about the small, the subtle, and the exquisite. This creature brings us to one of the most remarkable discoveries in all of paleontology: the intimate and surprising connection between these ancient reptiles and the birds we see flying overhead today. The compsognathus, with its small size and lightly feathered body, is a key piece of the puzzle that links the dinosaurs to their modern-day descendants. This isn't just an idea. It's a scientific reality, supported by a vast body of evidence. Modern birds are not just related to dinosaurs. They are, in fact, a surviving lineage of dinosaurs. The hummingbird that hovers over a flower in your garden is, in a profound and beautiful way, a tiny, vibrant echo of these ancient creatures. This link is a powerful example of biological continuity. It's the idea that life is not a series of disconnected events, but a long, unbroken chain stretching back through time. The compsognathus isn't just a fossil. It's a living bridge, a physical link between the Mesozoic era and our present day. When we see a bird build a nest or lay an egg, we are watching a behavior that has its roots in the ancient past, in the actions of creatures like the Oviraptor we talked about earlier. It's a powerful and humbling thought that something so ancient and so different can still be seen in the familiar world around us. There is a strange and beautiful detail about these small dinosaurs that remains a source of fascination. The fossil of one compsognathus was found with the fossil of a small lizard inside its stomach, perfectly preserved. This single quiet detail is a window into a moment that happened millions of years ago. A snapshot of a final meal, of a single unremarkable act of predation. But it raises a quiet question. What was this tiny creature's life like? Did it have a complex social structure, like a modern bird flock? Did it have a unique call or a song? The truth is, we don't really know for sure. The fossil record gives us the facts of its existence, but the poetry of its daily life, the rhythm of its heart, the flutter of its feathers, those things are left to our imagination. Thinking about the delicate compsognathus also reminds me of a subtle and beautiful process in our own bodies. Our eyes, which we use to see the world, are not just passive receivers of light. They have a kind of memory, a persistence of vision that allows us to see motion as a seamless whole. This is a concept called the phi phenomenon, where our brain perceives a series of images as continuous movement. It is this very mechanism that allows us to watch a movie and believe that what we are seeing is real. In a way, the fossil record is a bit like that, a series of static snapshots, and it is our job, with the help of science and imagination, to string them together to create a continuous, flowing picture of the past. The compsognathus is a ghost in the machine of time, a quiet whisper that reminds us that grandeur is not always measured in size. It teaches us that the story of life is one of resilience, of adaptability, and of a profound and beautiful connection that stretches from the deepest past to the smallest creature fluttering in a garden today. And so we leave this delicate ancient cousin of the hummingbird, and we move to a different kind of sound, a sound that we cannot hear, but can only imagine. We have journeyed from the small and delicate compsognathus, a living echo of our modern birds. Now we will encounter a creature whose legacy is a different kind of echo, one made of sound, a sound we could never hear. We are going to meet the parasaurolophus, a magnificent herbivore of the late Cretaceous, and a creature whose strange, backward-curving crest was a kind of ancient musical instrument. Imagine a large dinosaur, walking on two legs, with a duck-like beak perfectly suited for grinding plant matter. But what truly sets this creature apart is its head. Rising from its forehead and curving backward over its skull was a long, hollow tube of bone, a kind of elegant, bony trumpet. This crest could be up to 6 feet long, and was not solid but filled with a complex series of nasal passages, like a convoluted labyrinth within its head. For decades, scientists wondered what this strange structure was for. Was it a snorkel for breathing underwater? Was it a ramming tool for combat? The truth, as we have so often found, was far more interesting and beautiful than our first guesses. Paleontologists and engineers have created models of the parasaurolophus's crest and have simulated the sounds it could have produced. The result is a deep, resonating hum, a sound so low that you would feel it in your chest more than you would hear it with your ears. This sound, a kind of natural infrasound, was a form of communication. The parasaurolophus, it turns out, was part of a chorus of ancient creatures, communicating across vast distances, through the dense foliage of the prehistoric world, with a language that was a kind of geological base. This is a beautiful example of a core scientific concept, the physicality of sound. We often think of sound as an ethereal thing, a wave that exists only for a moment and then disappears. But sound is, in fact, a physical phenomenon, a vibration that travels through the air, through water, and even through bone. The parasaurolophus's crest was a physical structure designed to manipulate these vibrations, to create a specific frequency that could travel a long way, and through solid obstacles. It's a reminder that the world is filled with silent conversations, with frequencies and vibrations that are just beyond the range of our senses. Thinking about this prehistoric soundscape brings to mind a strange and little-known fact about our own planet. The Earth itself produces infrasound, a low, constant hum that is called microsysm. This sound is caused by the interaction of ocean waves and the sea floor, and it travels through the Earth's crust. It's a kind of constant low-frequency heartbeat of the planet, a sound that we cannot hear, but that is always there. This raises an interesting question. If we could somehow tune our ears to this frequency, what would we hear? A constant roar? A quiet hum? And what other sounds, what other frequencies are we missing in the world around us, both in our present day and in the deep past? The truth is, we don't really know for sure what all these unseen conversations sound like. The parasaurolophus is not just a collection of bones and a strange crest. It is a story about a different kind of communication, one that was felt as much as it was heard. It is a testament to the fact that the ancient world was not a silent, lumbering place, but one filled with a complex symphony of sounds, from the thunderous footsteps of giants to the deep, resonant calls of these magnificent creatures. Its story is a whisper in the wind, a low hum that invites us to listen a little more carefully to the world, to the things we cannot see and the sounds we cannot hear. And now we move to a different kind of giant, a master of a different kind of element. From the silent resonating calls of the parasaurolophus, our journey takes us upward, away from the ground and into the sky. But the creature we are about to meet is not a bird. It is a ruler of the ancient air, a pterosaur so large that it challenges our very notions of what is possible. We are going to meet the Quetzalcoatlus, a magnificent flyer whose wingspan was the size of a small plane, a kind of living, breathing dragon that sailed on the winds of the ancient world. Imagine a giraffe, but one that can fly. The Quetzalcoatlus stood as tall as a giraffe on the ground, with a long, slender neck and a massive, toothless beak. Its most remarkable feature, however, was its wings. These were not feathered like a bird's, but were made of a membrane of skin and muscle that stretched from an incredibly long fourth finger to its body. With a wingspan of up to 36 feet, the Quetzalcoatlus was the largest creature ever to take to the skies. It was not a land predator or a sea hunter, but a hunter of the air itself, using its long beak to snatch up small animals from the ground or the water. This magnificent creature forces us to confront the core scientific concept of aerodynamics on a scale we can barely comprehend. How could something so large and so heavy possibly fly? The answer lies in a combination of light, hollow bones, powerful muscles, and an intimate understanding of the ancient winds. The Quetzalcoatlus was not a flapper, like a hummingbird. It was a glider. It would have used its immense wingspan to catch thermals, rising columns of warm air, and soar for miles without a single beat of its wings. It was an elegant, graceful master of the skies, an architect of the air, using the forces of nature to its advantage. This is a powerful reminder that flight is not just about power. It is also about a kind of patient, silent cooperation with the world around you. The sheer size of the Quetzalcoatlus raises an interesting question that scientists are still grappling with. The physics of flight suggests that there is a limit to how large a flying animal can be. The forces required to take off, to generate enough lift to overcome gravity, are immense. The Quetzalcoatlus seems to push this limit to its very edge, and perhaps even beyond. The truth is, we don't really know for sure how it managed to become airborne from a standing start. Did it use its powerful legs to leap into the air? Or did it perhaps launch itself from a high cliff? This is an unsolved puzzle, a kind of beautiful mystery that is a testament to the fact that nature is often more ingenious than our models. Thinking about the Quetzalcoatlus and its immense size also brings to mind a strange and beautiful fact about our own physical world. It relates to the concept of scale invariance, a principle that suggests that the laws of physics are the same no matter the size of the object you are observing. In a way, the Quetzalcoatlus, the tiny compsognathus we talked about earlier, and even the smallest insect are all governed by the same rules of gravity and motion. Yet, their solutions to these problems are wildly different. A small insect can beat its wings with incredible speed, while the giant pterosaur must use the quiet, patient power of the wind. It's a reminder that while the rules may be the same, the game is played in countless different ways. The Quetzalcoatlus is not just a collection of fossilized bones. It is a metaphor for the limits of what we believe to be possible. It is a creature that seems to defy the very laws of physics, a kind of elegant silent poem written in the sky. Its story is one of impossible flight, of a life lived on the edge of what we can imagine. And so we leave this magnificent ruler of the ancient air, and we descend back to the ground, to a different kind of titan, one that was defined not by its flight, but by its sheer, staggering size. We have journeyed from the impossible flight of the Quetzalcoatlus, and we now return to the solid earth, to meet a creature that was a monument to gravity itself. We are going to drift alongside the sauropods, the immense long-necked dinosaurs, and contemplate the mind-boggling scale of their existence. These were the gentle giants of the Jurassic and Cretaceous periods, the living embodiments of an ecosystem that could support such staggering size. Imagine a living creature so long that it would take you a full minute to walk from its tail to its head. A creature so tall that its head could have reached to the 5th floor of a modern building. This is the sauropod. Dinosaurs like the Brachiosaurus, the Argentinosaurus, and the Diplodocus were the undisputed titans of the land. They were herbivores, their long necks allowing them to browse on the high leaves of ancient trees, much like a living crane. Their bodies were supported by 4 massive pillar-like legs, a kind of biological architecture designed to hold up impossible weight. This brings us to the core scientific concept of gigantism and the biological and mechanical challenges it presents. How does a creature of such size pump blood all the way up to its head? How does it get enough food to sustain itself? These are questions that force us to think about life in a different way. The heart of a sauropod would have been an immense, powerful organ, a kind of natural engine working constantly to defy gravity. Their long necks were not just for eating. They were also a kind of radiator, helping to regulate their body temperature. The very act of being a sauropod was a constant, immense biological effort, a quiet struggle against the limitations of flesh and bone. Thinking about the sauropod's immense size also makes me consider a strange and beautiful fact about our own understanding of gravity. Isaac Newton, the great physicist, famously used the falling of an apple to formulate his theory of gravity. But what if he had looked up at something that seemed to defy it? The sauropods did not defy gravity, of course, but their existence pushes the boundaries of what we might think is possible. Their presence on Earth for millions of years is a testament to the fact that evolution can find a solution to almost any problem, even one as immense as how to support a 100-ton body. There is a quiet mystery about the sauropods that remains. Their immense size suggests that they would have had a very slow, stable metabolism, but we don't know for sure. Were they slow-moving, plodding giants, or could they, despite their size, move with a kind of surprising grace? And what about their social lives? Did they live in herds, like modern elephants? The fossil record suggests they did, but we don't know the complexity of their social bonds. This raises an interesting philosophical question. Does great size necessitate a kind of slow, unhurried existence? Or is it simply a different kind of speed, a different kind of life, lived on a different clock? The story of the sauropods is one of a kind of quiet, patient grandeur. They were not roaring predators. They were the living landscapes of the ancient world. Their existence reminds us that there is a kind of power in being so big that you can simply ignore the smaller creatures around you. It's a story of a life lived on a scale we can barely imagine, a beautiful, impossible dream made of flesh and bone. And now, we leave these long-necked wanderers, and we move to a different kind of mystery, one defined by the strangeness of its form. We have journeyed alongside the long-necked titans, the quiet architects of the ancient forests. Now, our path takes a turn into a realm of pure, beautiful mystery. We are going to meet the therizinosaurus, a creature that looks like it was stitched together from parts of 3 different animals, a kind of beautiful, unsettling puzzle that has fascinated paleontologists for decades. Imagine a large, pot-bellied dinosaur walking on 2 legs with a small head and a long, slender neck. Now, add something completely unexpected: its arms. They were incredibly long, ending in 3 massive sickle-shaped claws, each one up to 3 feet in length. These were not the short, powerful arms of a carnivore, but something else entirely. For a long time, the only fossils we had of this creature were these immense claws, and scientists were left to wonder What kind of monster could have wielded them? Was it a fearsome predator? A slasher of its prey? A kind of nightmare creature from a forgotten past? The truth, as with so many of these stories, is far more surprising. We now believe that the therizinosaurus was not a carnivore at all, but a herbivore. Those terrifying claws were likely used for pulling down branches and stripping leaves from trees, or perhaps for digging for roots. This is a profound and beautiful paradox. A creature with the most fearsome claws of any known dinosaur was, in fact, a gentle vegetarian. It reminds us that our first impressions, based on the outward appearance of a thing, are often wrong. The claws were not a weapon of violence, but a tool for living, a kind of natural scythe for navigating its place in the world. This brings us to a quiet but fundamental concept in paleontology: the gaps in the fossil record. The truth is, we don't have a complete picture of life. We only have the fragments that have been preserved by the delicate and rare process of fossilization. The therizinosaurus is a perfect example of this. For decades, we had a single, isolated piece of the puzzle, a massive claw, and we tried to construct a whole picture from it. As more pieces were found, the picture changed, from a fearsome predator to a quiet herbivore. It's a powerful reminder that our knowledge is never complete, that there are always blank spaces in the story, waiting to be filled in by a new discovery. This raises an interesting question. What other creatures, what other beautiful paradoxes are waiting to be found? Their stories just below the surface of the earth. Thinking about the mystery of the therizinosaurus's claws also makes me contemplate a beautiful and little-known fact about the human body. Our own hands, with their incredibly complex system of bones, muscles, and nerves, are a kind of natural tool, a testament to our own evolution. The human thumb, with its ability to oppose the fingers, is one of the key factors that has allowed us to manipulate our environment and build the world around us. In a way, the therizinosaurus's claws and our own hands are both expressions of a similar evolutionary drive: the need to interact with the world and to get the things we need to survive. The story of the therizinosaurus is a reminder of the quiet mysteries that still exist in science. It is a testament to the fact that the most incredible discoveries are often the ones that challenge our assumptions and force us to think differently. It is a story of a gentle giant with a terrifying facade, a kind of beautiful contradiction that invites us to look closer, to dig a little deeper, and to never assume we know the full story. And now, we leave this puzzle of a creature, and we move to a different kind of re-evaluation, to a dinosaur that we thought we knew, but whose story has been completely and wonderfully rewritten. From the strange, gentle contradiction of the therizinosaurus, our journey takes us to a creature we thought we knew, a kind of cultural icon that has been reimagined and re-envisioned countless times. We are going to reconsider the Tyrannosaurus rex, not as the scaly monster of old, but as a feathered predator, a kind of beautiful and magnificent bird of prey. For generations, the T-Rex has been a symbol of brute force, a scaly green roaring beast that chased jeeps and stomped through jungles. But like the Oviraptor, our understanding of this creature has been completely and wonderfully rewritten. We now believe, based on a growing body of evidence from its relatives and preserved fossil impressions, that the T-Rex and many other large theropods were covered in a kind of downy fluff, a coat of primitive feathers. This doesn't make it any less terrifying. In fact, it makes it more so. Imagine a creature of immense size, covered in what looks like a kind of soft, feathery coat, a quiet and elegant predator with a powerful presence. This re-evaluation of the T-Rex is a perfect example of a beautiful process in science, a kind of scientific humility. It's the idea that our knowledge is always provisional, that the picture we have today is subject to change with new evidence. The T-Rex is no longer a static image. It's a living, breathing idea that has been shaped and reshaped by every new fossil we find. This is a crucial distinction. Science isn't a set of unchanging facts. It's a method of inquiry, a way of getting closer to the truth, one discovery at a time. The T-Rex is a testament to this, a living record of how new information can completely overturn our most deeply held assumptions. The idea of a feathered T-Rex also brings to mind a strange and little-known fact about evolution that scientists are still grappling with. It's a concept called atavism, where an ancient dormant trait reappears in a modern creature. For example, some modern whales are born with a small vestigial pelvis and leg bones, a ghostly echo of their land-dwelling ancestors. This raises an interesting question. What other ancient dormant traits are we carrying around in our DNA, waiting for the right conditions to reappear? And what does this tell us about the long, winding, and often unpredictable path of evolution? The T-Rex's story is a profound one because it forces us to confront our own biases. We wanted a monster, a clear villain, but the universe gave us something more complex and more beautiful. The feathered T-Rex is a reminder that the past is not a simple black and white picture. It is a full-color, textured tapestry that is constantly being revealed. It's a detective story played out over millions of years, with each new fossil serving as a clue. Thinking about the T-Rex's new feathery appearance also reminds me of a subtle and beautiful fact about light and color. We see color because of the way objects absorb and reflect certain wavelengths of light. A green leaf, for example, is reflecting green light and absorbing all the other colors. But what if the T-Rex's feathers were not just for warmth or display, but were also used for communication, for a kind of vibrant, silent language? We don't know what colors their feathers were, but it's a beautiful thought, a kind of silent painted veil that has been lost to time. The story of the T-Rex, a creature of legend, is a story about the quiet, patient work of science. It's a story about a humble shift in perspective that reveals something far more beautiful and far more real than the monster we first imagined. And so, we leave this feathered tyrant, and we move to a different kind of titan, one that was a kind of living bridge between two worlds. From the reimagined feathered T-Rex, we travel backward in time, to the Triassic period, to meet a creature that was a kind of living bridge between two worlds. We are going to contemplate the Plateosaurus, one of the earliest large herbivores, and a kind of transitional species that helps us understand how the long-necked titans we discussed earlier came to be. Imagine a dinosaur that stands on two legs but has the body of a much larger four-legged creature. The Plateosaurus was not as immense as the later sauropods, but it was still a giant for its time, reaching up to 30 feet in length. It had a long neck and a small head, and its hands had a kind of grasping ability, with a large thumb which might have been used for pulling down branches. What makes this creature so fascinating is that it was not yet fully committed to the quadrupedal life of the later sauropods. It was a kind of transitional form, a halfway point between the small two-legged dinosaurs and the great four-legged herbivores of the Jurassic. This is a beautiful example of a core scientific concept, the idea of transitional species. A transitional species is a fossilized creature that shows a mix of traits from a species that came before it and a species that came after it. The Plateosaurus is a perfect example of this, with its bipedal stance and its long neck, a kind of living record of a major evolutionary shift. It's a powerful reminder that evolution is not a series of sudden dramatic leaps, but a long, slow, and often messy process. The Plateosaurus is a moment in time, a snapshot of a slow and patient unfolding of a new kind of life. Thinking about the Plateosaurus also makes me consider a strange and beautiful fact about our own planet. The Earth's continents are not static. They are in constant slow motion, driven by the quiet power of plate tectonics. The world that the Plateosaurus lived in was different from the world of the later dinosaurs. The supercontinent Pangaea was just beginning to break apart, and the continents were slowly drifting away from each other. This raises a quiet question. What impact did this grand, slow movement have on the evolution of life? Did the slow separation of land masses create new opportunities for species to diverge and specialize? The truth is, we don't know for sure how these grand geological changes influence the day-to-day lives of these creatures. But it is a beautiful thought that their world was literally in a state of flux. The Plateosaurus is not just a collection of old bones, it is a testament to the idea of change. It is a living record of a world in transition, a kind of elegant, quiet, and monumental shift that took place over millions of years. It reminds us that even the most stable things are in a constant state of becoming something new. And now we leave this living bridge, and we move to a different kind of discovery, one that has brought a new kind of vibrancy to the past. From the grand evolutionary sweep of the Plateosaurus, our journey narrows, focusing on a single, astonishing detail that has completely changed our view of the ancient world. We are going to encounter the Sinosauropteryx, a small feathered dinosaur from China. and the creature that gave us the very first glimpse of a dinosaur's true colors. Imagine a small dinosaur, no larger than a turkey, covered in a kind of primitive fuzzy feathering. But what makes this creature so remarkable is not just its feathers, but what was preserved within them. When scientists looked at the fossils of the Sinosauropteryx under a microscope, they found tiny preserved structures called melanosomes, the organelles that contain pigment. By studying the shape and arrangement of these melanosomes, scientists were able to deduce the colors and even the patterns of the dinosaur's feathering. The Sinosauropteryx, it turns out, was not a dull gray creature, but a kind of ancient tabby cat, with a striped tail and a reddish-brown coat. It was a kind of beautiful living canvas, a painter's palette brought back to life after 125 million years. This discovery is a powerful example of a core scientific concept: the fossilization of soft tissue. For a long time, we thought that only hard things like bones and teeth could be fossilized. But in certain rare and specific conditions, like the fine volcanic ash of a lakebed, even the most delicate structures can be preserved. This discovery has opened up a whole new world of inquiry. We can now begin to ask and answer questions that were once thought to be impossible, like what color a dinosaur was. It is a testament to the fact that the Earth is a kind of patient archivist, a kind of library of all the life that has come before. And we are just beginning to learn how to read its most delicate passages. Thinking about the Sinosauropteryx and its vibrant colors also brings to mind a strange and beautiful fact about the physics of light. The colors we see, whether on a modern-day bird or a fossilized dinosaur, are not a property of the object itself, but a property of the light that is reflected from it. The red in the Sinosauropteryx coat was a kind of ancient reflection, a quiet echo of a prehistoric sun. This raises an interesting philosophical question. When we look at a fossil, are we seeing a ghost? Or are we, in some strange and beautiful way, seeing a physical remnant of a light that shined millions of years ago? A kind of living mirror of a world that is long gone. The story of the Sinosauropteryx is a profound one. It is a story about the sudden vivid burst of color that a single discovery can bring to a world that was once thought to be black and white. It is a story about the quiet patience of science, about looking a little closer, and seeing a world that is far more beautiful and far more vibrant than we ever imagined. And so, we leave this ancient masterpiece, and we move to a different kind of artist, one that was not known for its color, but for its quiet, grinding strength. From the quiet painted world of the Sinosauropteryx, we now journey to a different kind of craftsman, a kind of living sculptor of the ancient earth. We are going to meet the hadrosauridae, the duck-billed dinosaurs, and we will contemplate the immense and quiet power of their unique way of eating and how it shaped the world they lived in. Imagine a dinosaur with a mouth full of more than 1,000 teeth. The hadrosauridae, a family of large herbivores, had a bizarre and beautiful dental system, a kind of natural, self-sharpening grinder. Their teeth were not a single set, but a series of stacked, interlocking rows that formed a kind of dental battery. As the top layer of teeth wore down, a new layer would grow in from below, like an endless conveyor belt of grinding surfaces. This incredible system allowed them to chew and pulverize tough plant matter, from ancient conifers to tough ferns. The jaw muscles of a hadrosaurid were so powerful that they could have generated an immense amount of force, turning a mouthful of ancient plants into a fine mulch. This beautiful and complex system is a perfect example of a core scientific concept: the relationship between diet and anatomy. A creature's body is a direct reflection of what it eats. The teeth of a carnivore are sharp and pointed, designed for tearing flesh. The teeth of a herbivore are broad and flat, designed for grinding plant matter. The hadrosauridae took this to a beautiful and astonishing extreme. Their dental batteries were a kind of elegant, quiet solution to a fundamental problem: how to get enough energy from tough, low-quality food. They were the ultimate grinders, a kind of living mill that processed the ancient world, and in doing so helped to shape it. Thinking about the hadrosauridae and their quiet grinding work also makes me contemplate a strange and little-known fact about our own planet. The Earth's soil, which we often think of as a passive medium, is in fact a complex and living ecosystem, a kind of natural archive of all the life that has come before. The hadrosauridae, with their immense consumption of plant matter, would have returned a significant amount of nutrients to the soil in the form of waste. They were, in a very real way, the landscapers of the ancient world, a kind of biological engine that helped to shape the very earth they walked on. There is a quiet mystery about the hadrosauridae that remains. While we know a great deal about their teeth and jaws, we don't know the full extent of their behavior. Did they live in immense herds, like modern bison? The fossil record suggests they did, but we don't know the complexity of their social bonds. Did they communicate with a kind of silent language, like the parasaurolophus we talked about earlier, or with a different kind of sound? The truth is, we don't really know for sure. This raises a quiet philosophical question. Does a life lived in a herd have a kind of collective consciousness, a kind of shared purpose that we, as solitary creatures, can only guess at? The story of the hadrosauridae is one of a kind of quiet, patient strength. They were not known for their roaring or their ferocity, but for their ability to simply eat, to process and to live. They were a testament to the fact that power can be found in stillness, in repetition, and in the quiet, patient work of simply existing. And so, we leave these ancient sculptors of the earth, and we move to our final destination, a quiet reflection on all the strange and beautiful creatures we have encountered. From the quiet, grinding work of the hadrosauridae, we now arrive at our final reflection, a kind of poetic summary of all the strange and beautiful creatures we have contemplated. We will revisit all these stories, from the small and delicate to the immense and armored, and we will weave them all together, bringing our journey to a gentle close. Remember the Oviraptor, the egg thief, who turned out to be a devoted parent? Its story reminds us that our first glance is never the full picture, that a deeper look can reveal a truth far more beautiful and complex than we first imagined. Then, we dove into the ancient sea to meet the Mosasaurus, the not-quite dinosaur that was a master of convergent evolution, a testament to the elegant logic of nature, which so often finds the same solution to the same problem, whether it's for a fish, a mammal, or a reptile. We return to the land to meet the ankylosaurus, a living fortress of bone, and a kind of patient sculptor of the ancient earth, a testament to the quiet, unyielding power of defense. From there, we met the spinosaurus, the sailing predator of the rivers, a creature that chose a different path and became something truly unique, a kind of living ship. We then shrank in scale to meet the compsognathus, the ancient echo of a hummingbird, a reminder that the grand story of the dinosaurs is also a story of the small and delicate. We heard the silent call of the parasaurolophus, its crest a kind of ancient musical instrument, a testament to the physicality of sound, and the unseen conversations that take place all around us. We soared with the Quetzalcoatlus, the ruler of the ancient air, and a kind of beautiful impossibility that reminds us that nature often pushes the boundaries of what we believe to be possible. We then contemplated the long-necked sauropods, the quiet, patient giants, a testament to the grand biological challenges of simply existing. Then, we puzzled over the therizinosaurus, the gentle herbivore with the terrifying claws, a kind of beautiful contradiction that reminds us that we can never judge a book by its cover. We reimagined the T-Rex, not as a scaly monster, but as a feathered predator, a kind of beautiful and humbling re-evaluation that reminds us that science is a living, breathing process, not a static set of facts. We looked at the Plateosaurus, the living bridge between two worlds, and a kind of testament to the quiet, patient process of change. And we were given a glimpse of a different kind of vibrancy with the Sinosauropteryx, the dinosaur that gave us a glimpse of a world that was far more colorful than we ever imagined. Finally, we looked at the hadrosauridae, the quiet grinding sculptors of the ancient earth, a testament to the immense power of stillness and repetition. The truth is, we don't really know for sure what all these creatures were like. We have their bones, their fossilized remains, but the full story, the poetry of their existence, is left to our imagination. This raises a beautiful, quiet question. What is a fossil? Is it just a collection of old bones? Or is it a kind of quiet promise, a living invitation from the past, asking us to look a little closer, to think a little deeper, and to never stop being curious about the world that has come before? These creatures are not just relics, they are storytellers. They tell us a story of a world that was wilder, more beautiful, and more strange than we could ever invent. They remind us that the Earth is not just a place where we live, but a place that has been lived in for millions and millions of years by creatures so beautiful and so bizarre that they challenge our very notion of what is possible. And now, as we gently bring this journey to a close, I'd like you to do something with me. We have traveled so far, across so many millions of years, and we have met creatures of impossible beauty and form. We have revisited the gentle Oviraptor, the aquatic mosasaurus, the armored ankylosaurus, and the graceful sailing of the spinosaurus. We have shrunk to the scale of the delicate compsognathus and heard the silent low hum of the parasaurolophus. We have soared with the impossible Quetzalcoatlus and stood in the shadow of the sauropods. We have puzzled over the contradictions of the therizinosaurus, and we have seen a new kind of elegance in the feathered T-Rex. We have looked at the living bridges of the Plateosaurus and the vibrant colors of the Sinosauropteryx. And we have contemplated the patient, grinding work of the hadrosauridae. The final waltz of the Titans is not just a dance of bones and fossils. It's a waltz of ideas. It's a dance between our assumptions and the quiet, surprising truth of the past. It's a gentle reminder that the world is a book with many chapters, and we are only just beginning to learn how to read them. Each creature we have met is a single beautiful word in that book, and together, they tell a story that is far grander and more complex than we could have ever imagined. This journey from the deepest past to the present moment is a circle. We began with a question about what was, and we end with a reflection on what is. The truth is, the world we live in is not separate from that ancient world. The oxygen in the air you are breathing now, much of it was once breathed by these same creatures. The very ground you are resting on is made, in part, from the dust of their bones. We are all connected, a long and unbroken thread stretching back through time, from the first spark of life to the quiet moment you are in right now. Think of it like this. The time between the T-Rex and the Stegosaurus is longer than the time between the T-Rex and us. It is a scale that our minds struggle to comprehend, but our hearts can feel. It is a humbling and beautiful realization that we are living on a planet that has been shaped by so many different lives, so many different forms, so many different beautiful mistakes. The weirdest dinosaurs that ever lived are not just a curiosity. They are a kind of quiet lesson, a reminder that the universe is far stranger and far more wonderful than we could ever dream. And now, as we reach the end of this long journey, I invite you to simply close your eyes and to gently return to the quiet space you are in. I'd like to gently ask one last time, where is the place you're staying now? The time in that place at this very moment, how is it flowing? I'd like you to let the great beasts of the past, the armored, the feathered, and the impossibly large, gently brush past your mind, like clouds on a summer day. Their stories are now a part of you. Let the long neck of the sauropod become a kind of quiet thought, stretching out into the vastness. Let the gentle feathers of the Oviraptor become a kind of soft, comforting weight in your mind. Let the silent, unheard hum of the parasaurolophus slowly fade into the quiet sounds of your own room. The journey is over. The pages of this ancient book are now turning, and they are bringing you back, slowly, gently, to the here and now. The world is full of mystery, both in the past and in the quiet of this very moment. But you are here, and you are safe. Sleep well, my companion, wherever and whenever you are. Sweet dreams,